Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in BE 5th semester. Today we will discuss some problem on belt and wheel turbine. The following data is related to a belt and wheel. Head at the base of nozzle is 80 meter. Diameter of jet is 100 mm. Discharge of nozzle is 0.3 meter cube per second. Power at the shaft power is 206 kilowatt and power absorbed in mechanical resistance 4.5 kilowatt. Determine power loss in nozzle and power loss due to hydraulic resistance in runner. The data given here: head at the base of nozzle H1 equal to 80 meter, diameter of jet D equal to 100 mm, 100 mm equal to 0.1 meter. So area of jet equal to pi by 4 d square 0.1 square. So the value is equal to area equal to 0.007854 meter square. Discharge of nozzle Q is given 0.3 meter cube per second. Shaft power is given 206 kilowatt. Power absorbed in mechanical resistance is 4.5 kilowatt. Now discharge equal to A V1. So this is 0.3 equal to 0.007854 into V1. So here the value of V1 comes 38.197 meter per second. Now we have to calculate the power at the base of nozzle in kilowatt. Power in kilowatt equal to rho GQH by 1000 rho GQH by 1000. The value of rho for water is 1000. G is 9.81, Q is 0.3 and H is equal to 80 meter, that divided by 1000, cancelling this 1000. So here the power in kilowatt is 235.44 kilowatt is the power. Now power corresponding to kinetic energy of the jet in kilowatt. Power corresponding to kinetic energy is half of mv square half of mv 1 square and here all in the kilowatt, so this is divided by 1000 to convert this kinetic energy in kilowatt. Now putting the values here, half of value of mass is rho q v1 square by 1000. Here the value of A and V is replaced by Q. Now putting the values, value of rho is 1000, Q is 0.3 and V1 is 38.197 by 1000. Cancelling this 1000, this power correspond to kinetic energy comes 218.85 kilowatt. Now we have to calculate the power at the base of the nozzle. Power at the base of the nozzle. Power at the base of nozzle. Nozzle is equal to power of jet plus power of nozzle. Power of jet plus power of nozzle. Power lost in the nozzle. Power lost in nozzle. So here this is 235.44 equal to 218.85 plus power lost in nozzle. Power lost in nozzle. So this power lost is equal to, power loss comes 16.59 kilowatt. Now next we have to calculate power at the base of the nozzle. Power at the base of nozzle equal to power at the shaft. Power at the shaft plus power lost in nozzle. Just power lost in the power lost in the plus power lost due to mechanical resistance. Power lost due to mechanical resistance. This comes to 30 5.44 equal to 206 plus 16.59 plus power lost in runner, plus 4.5. So the power lost in runner comes 8.35 kilowatt. This is a different type of question. This is not a routine type of question. Here these power lost have been taken in consideration. So these different type of questions are also asked in examination. So you have to take care of different type of questions also, and we will continue. Next point is design of Pelton wheel. Design of Pelton wheel means following data is to be determined, where first data is diameter of jet, it is generally represented by small d. Second important data is diameter of wheel, it is generally represented by capital D. Next is width of bucket, that is generally this is considered 5 times of diameter of the jet. Then next, depth of bucket, it is generally considered as 1.2 times diameter of jet. And next important point is number of bucket on the wheel. Size of bucket means the width and depth of the bucket. So sometimes it may be asked in place of width and depth, that is size of the bucket. As we have discussed earlier, the type of bucket is of spoon, double type spoon. This has been fixed on the runner, and this is like the center is like this. This is the center point here. From here water enters, and either water can go this side, reflecting, diverting from this, or this side. Means some water enter in this side and some water enter in this side, and on rolling this the water comes out. Okay, so this we have to calculate, and we will take some more numericals in our next classes. Thank you.